To the flat earthers, the cosmic tide phenomenon provide insight into the gravitational effect of celestial bodies, particularly the moon and the sun, on Earth ocean water. This phenomenon help to support the understanding that the Earth is not flat for several reasons. When the moon is on one side of the Earth, its gravitational pull attracts the seawater in that area, forming a badge of water, which is known as the tide phenomenon. On the side of the Earth farthest from the moon's gravitational pull is relatively weaker, while the centrifugal force is relatively stronger. That is, another high tide is formed and the middle part becomes a low tide area. Therefore, at the same time, there are two high tide areas and two low tide areas on Earth. And because the Earth rotates once approximately every 24 hours, this results in the same location experiencing two high tide and two low tide within a day. The gravitational pull of the sun also affects the tide, but its effect is weaker when the sun, earth and moon are aligned in a straight line. The gravitational forces of the sun and moon combine to create a spring tide. When the sun and moon form a right angle, the gravitational forces partially cancel each other out, resulting in a mid-tide. Therefore, the following reasons support our understanding that the earth is not flat. Number one, gravitational forces. The tides are caused by the gravitational pull of the sun and the moon on earth. What in a flat earth model, the gravitational effect will not work the same way. A flat earth surfaces will not exhibit the same tidal bulge that we observe on a spherical earth. The significant variation in tidal height and pattern around the globe can only be explained by the earth curvature and its rotation. Two, tidal patterns and phases. The way tide rises and falls in a predictable cycle reflects the Earth's spherical shape. As the Earth rotates, different areas move in and out of the gravitational influences of the moon and the sun, creating distinct tidal patterns. These patterns can be predicted and are consistent over time. If the Earth were flat, such synchronization and predictable pattern would be less likely to exist. Three, observation from different locations. Observation of tides in different locations shows that they occur at varying time and height, depending on the position of the moon and the earth curvature. For example, high tide in one location might occur at a different time than the other, which align with a spherical model where different location experiences varying degree of gravitational pull. 4. Total tidal effect. The concept of tide also incorporates the idea of the earth and water as part of a larger gravitational system affected by the sun and moon in a three-dimensional space. The interaction of these bodies and the shape of the earth leads to a complex dynamic system that cannot be adequately explained with a flat earth model. The comprehensive understanding of tides supported by physics and observed phenomena provides strong evidences that the earth is not flat but rather an obsolete spheroid. Follow us for more space update. Thank you.